To start this problem, I'm going to start by drawing a forced body diagram of the pole. So I will have my pole. I will have the force of the lamp. I will have the force tension of the rope, and I will have some reactive force, both normal force and frictional force, from the base. And I'll call that F base, and I don't know much about that. I will need to find that in part B. I guess they call it the force of the beam. So, because I don't know the force of tension or the force of beam, I will need to use torque to find my forces. So I'm going to draw my pivot point at the beam because I don't know anything about that. And I'm going to sum the torques to find the tension. Now I can sum the forces around the beam because it is not rotating, so I can sum the torques anywhere. So sum of my torques is going to be equal to 0, and that will equal the force from the lamp, so which is equal to force of the lamp times some distance r, and the distance r is this distance here, and that will be negative. I'm going to use my right hand rule, and I know that going this way is positive, going that way is negative. If you're having trouble, place your hand on the paper curved in that way, and you'll see that thumbs up is positive, thumbs down is negative. Alright, so that will be negative, and I'm going to add the torque from the string. Now, if you remember, your equation for torque is equal to R cross the force. And that cross here means the amount that's perpendicular. So the torque is equal to R times the perpendicular force. In this case, my force that's perpendicular is going to be my force tension sine of my angle times the distance r. So I'm going to write this here, and I'll rewrite it on the new screen. So force tension times sine theta to get the perpendicular part times r. Now, so I'm going to get a new slide. So sum of my torques will equal negative the force of the lamp times r plus the force of tension sine theta times r will equal 0. Alright, so the force from the lamp is going to be equal to the force of gravity of the lamp, and you could draw a free body diagram of that lamp to show you that. So negative 20 kilograms times 9.8 meters per second squared times some distance r plus ft sine theta times r will equal 0. Alright, so I will rearrange that, and I will get 196 newtons times r will equal ft times 1/2 times r. So my r's cancel out, and I should get that my force of tension is equal to 392 newtons. And that is the end of part A. For part B, I'm going to go back to my free body diagram. Now I know that I have 392 newtons going that way and 196, sorry, 6 newtons going down from the lamp, and they're asking what is the force from the beam. So I can think about that as some force beam in the x direction and some force beam in the y direction. So to find the force beam in the y direction, I'll do sum of the forces in the y, and that's going to be 392 sine 30 minus 196 newtons will equal 0. So, plus F beam y equals 0. So, what I find is that F beam y will equal 0 newtons. Now, to find the forces in the x, I'm going to do that, and I'll do that in blue. And that's going to be this component here plus the x component of the tension. So sum of the forces in the x direction, I will have 392 cosine of 30 plus, and that's going in the negative direction, plus FBX is going to be equal to 0. So FBX will equal 392 cosine of 30. So FBX equals 339 newtons. That is all.